Hello, so today we are going to talk about density and we're going to work out a few density problems and remind you of how to work out a few density problems, and then you'll have some time to work out some problems in small groups, and we'll talk about your lab that's going to happen. So here you have some gold, and it's just a way to introduce the section because it's funny. Back in the day, all of the movies would have these robbers stealing these big pieces of gold. Well, if you know anything about gold, you know just how heavy it is, also how malleable it is. So it's kind of funny to watch these old movies where they had these big golden blocks that they were able to move around. There used to be, like, banks used to have a cubic foot of gold in their vaults and say if you can actually lift it up, you'd be able to take it out. And of course, no one could actually physically lift it up. So it's kind of funny to watch those things. So why is this important? Because yesterday we talked about, or last class period rather, we talked about matter. And we said that matter is the study of, we talked about chemistry, and we say chemistry is the study of matter and the changes that it undergoes. So, like, basically observations associated with matter. So then after that, we decided, or we went through and we decided to define what is matter. And we came up with the definition that matter is anything that has volume and has mass. Well, if something has a mass and has a volume, then we say that those things can be classified for their density. And density is an intensive property, meaning the density of something stays the same no matter how much of it that you have. So with that being said, we're going to talk about how can you work out density problems. So you'll see here that the equation for density is mass divided by volume. Now, mass can be in grams. You may also see mass in kilograms. And volume can be in milliliters. And another unit for milliliter, or another unit that's similar to the milliliter, is centimeter cubed. Or you may even see liters or meters cubed, depending on the problem. Okay? So the example problem says, what is the density of a billiard ball that has a volume of 100 centimeters cubed and a mass of 250 grams? So we have our volume here, 100 centimeters cubed, and we have our mass of 250. Well, density is equal to mass over volume. Okay, so if the mass is 250, I'm going to take so that's going to be equal to 250, and then I'm going to divide that by the volume, which was 100, and you see that's what's done here. And when I do that, let me erase that so you can see. When I do that, I get 2.5 grams per centimeter cubed. So for those of you who hate setting up math problems, I'm going to show you the density triangle, and I'm sure that maybe Mr. Konechny showed you this density triangle last year, but I'm going to go ahead and show you again. The density triangle looks like this. And how it works is whatever you're looking for in the problem, you cover that letter up. And the rest of the remaining variables will tell you how to solve it. So for example, in the last problem, we had to solve for density. So if you cover up density, and I'm covering it up by coloring it in, what am I left with? I'm left with mass over volume. So density is equal to mass over volume. Okay, let's back up some. Let's say gonna erase that. All right, good. Let's say that I'm looking for mass in a problem. So this time I'm looking for mass. I'm gonna highlight that in green. So I'm gonna cover up mass, and I'm left with density times volume. So mass is equal to density times volume. And let's say I'm going to just use a different color here. See if it'll let me. There we go. So let's say that I'm trying to do volume. So the question is asking for volume this time. Again, I can cover up volume because I'm not using volume right now, so I can cover that up. And so what am I left with? M over D. So the equation for volume equals mass divided by density. So let's just go over that one more time, make sure you understand it. So density is equal to mass over volume. Mass is equal to density times the volume. And volume is equal to mass over density. And of course, don't forget your units. So if something's in mass, it's going to be grams or kilograms depending on the problem. You're going to make sure you do your density in the right units, and you're going to make sure that you also do your volume in the right units. All right, so let's do some practice problems, shall we? So we're going to move on. And let's talk about, so that's easy when you have things where you're given the mass and the volume. But what about if you have a regular or irregular object? What are you going to do? The easiest way to do it is you will start with a certain volume of the liquid. So let's say you had this rock, like the one on the screen here. And you started, if you look here, you read the meniscus, you started with about 50 milliliters of water. Okay? And so what you do is you then drop your rock or whatever your irregular shaped object is in the water. So we just did that here, and you'll see what happened to the volume. Here it went up to about 75 milliliters. Yeah? So if the water was only 50 mils, but when I dropped it in, it rose to 75 mils, well, what's the volume of that rock? Easy. You take the final volume and you subtract it from the initial. So in this case, that's going to be 75 minus 50, which is equal to 25 mils. So that means this rock has a volume of 25 mils. And so from here, if I knew the mass, like if I had a balance and I could do the mass, I know the volume is 25. I can type in the mass and do density equals mass over volume and work that problem out. So this little slide tells you exactly what to do. You measure the volume of the liquid in the partially filled graduated cylinder. And then you add the solid. And when the solid is submerged, you will see that the volume rises up. And then to get the actual volume of that solid or that object that you put inside of the graduated cylinder, you would take the final volume and subtract it from your initial volume. As I stated in the beginning slide, density is an intensive property. That means it does not depend on the amount of matter present. So if you look up here, aluminum, it says 2.643 grams per centimeter cubed. It does not matter how much aluminum I have. That will always be the volume the density of that aluminum. So density does not change when you have more matter. So you have to remember that. So for water, for example, water is 1 gram per milliliter, right? Water is not going to change. So depending on what you have, it's not going to change. So this is just a chart that shows you all of the different densities. Now, density is about, as I stated, it's about 1 gram per centimeter cubed or 1 gram per milliliter cubed. If something is more dense than the water, it's going to sink. If it's less dense, it's going to float. In other words, if it's heavier, it's going to sink. If it's lighter, it's going to float. So whenever you look at something, if it has a density after you calculate it, if the density is less than 1, that means it would float on top of water. If the density is greater than 1, then that means it will sink. So when you ask yourself a question, and we'll show you down here if you look at this chart, man, why does ice seem to float on top of water? Well, when ice is frozen or water is frozen, the density is about 0.897. The density of liquid water is about 1. So because that 0.897 is slightly less than 1, of course the ice then rises and floats in your water. If you didn't know, now you know. Let's take a moment right here to make sure we understand what was said so far. So we're going to take a break and we're going to pause this video. And we're back. So what we're going to do right now is I'm going to work out 2 density problems before I put you in your small groups to make sure that you know how to work them out. So let's look at this problem together. Problem states, what is the mass? So take a moment. What variable is for mass? I hope you're thinking M. So what is the mass of 600 milliliter sample? 600 milliliter. Is that density or volume? Yes, it's volume of seawater with a density of 1.025 grams per milliliter. My gram got kind of cut off a little bit, but that's grams per milliliter. So 1.025 grams per milliliter. All right, so if you see over here, we'll zoom in, you see my density circle. You know that density is equal to mass over volume. Well, if you look at my density chart here, and I'm covering up mass because that's what I'm looking for. So let me highlight that. You see I'm going to do density times volume, right? So mass is equal to density times volume. All right, perfect. So we're going to zoom back out. We can set up our problem now. Density is equal to mass over volume. So mass is equal to density times volume. So mass is equal to 1.025 times 600. So then you'll take that and you'll plug it into your calculator. And you will get 615. Now, if my units for density is grams per milliliter, that means the mass is grams. So my answer is 615 grams. Slide back over. So which answer is that? It's B. Let's take a moment to discuss this problem. Okay, so now we're going to work on our final problem before we start working in groups. And we are going to work on this problem, because this problem also helps us to understand that density is an intensive property. So we have this information here, and it tells us a cube of an unknown metal has a volume of 2.25 centimeters cubed, and volume is V, and it has a mass of 16.2 grams. That's M. So we know density is equal to mass over volume. So in this case, that's going to be density is equal to, our mass is 16.2 and our volume is 2.25. So I'm going to plug that into my calculator. 16.2 divided by 2.25, and I get that density is equal to 7.2 grams per centimeter cubed. Perfect. Now I'm going to go over here to my chart and look at my chart and see what it says about density and which density matches up with 7.2. You're looking at this row? Yeah, this table tells me that any type of chromium, it doesn't matter if it's small, big, large, it's going to, or medium, large, it's going to have the density of 7.2. So I calculated 7.2. So that's obviously my answer. So I'm going to go with B, chromium. Okay, that's it for this lecture portion. What we're going to do now is break out into small groups and make sure that everybody works a problem. And I will be traveling into each of the different rooms to help you out with problems, and you and your partner will work through problems together today. So you're going to actually do this in your Kim book, and I'll explain that in a second. Thanks for listening.